This video is going to take you through operating on rational expressions with emphasis on multiplication. It's the most straightforward operation that we have, and as we go through the different operations, I'm going to show you some different ways that you can approach that. So the title of this lesson is Operations on Rational Expressions, and like I said, we're going to go through them one at a time. So rational expressions, just to kind of review some of the vocab, when we're talking about rational expressions, the word ratio is embedded in that. And so what we're talking about are fractions. But when we're using the expression or term rational expressions, we mean like really big, ugly fractions that have lots of polynomials in them. But they do behave as fractions do. And so because math is consistent and the rules that we learn for adding, subtracting, multiplying, and dividing fractions that have numbers in them also work with polynomials in the fractions, but it does require integrating your fraction skills with your polynomial skills, and so they can get really, really messy. The easiest operation to perform on fractions is multiplication. So we're going to start with that one. Okay, and so to review, when you multiply fractions, you simply multiply straight across. So if you have a over b times c over d, that is equal to ac over bd. You just simply multiply them together. So an example with numbers might be if you had, what did I have written down? 1 over 2 times 2 over 3. Okay, and you would just multiply straight across. So 1 times 2 is 2, and 2 times 3 is 6. Okay, and then once you get there, then you can simplify, and 2 over 6 simplifies to 1/3. But here's the deal. When we multiplied that together, so if you take a close look at what happened with the numbers here, we multiplied 1 times 2 and then multiplied them to get the 2, and then the 2 times 3 to get the 6. But if I were to simplify this, the way I would go about simplifying it is I would factor these and cancel the common factors. So how would I factor the 2? I would factor it into 1 times 2. And how would I factor the 6? Into like 3 times 2. And then I would cancel out the common factor of 2. What we can do then is we can actually cancel that out before we multiply, because literally all we did was we multiplied it and then we'd be factoring it or unmultiplying it in order to simplify it. And so the way a lot of people would prefer to do that is they would do 1 over 2 times 2 over 3, and they would cancel the 2's out beforehand, and that would leave you with the 1/3, or you'd have like 1 times 1 over 1 times 3. And so that gives us a really good strategy for approaching these problems. They're pretty much the same as what we covered in the last lesson with simplifying the rational expressions, except that now we've got this multiplication symbol between them, but it doesn't change any of the math. So here's the key idea. Okay, and we do want to focus our math knowledge on those key ideas. So the key idea here is that we factor, then we can cancel out the common factors. Okay, so essentially what we're going to do is simplify it first. So we'll factor it, we'll cancel the common factors, and then we'll multiply. So a numerical example of that would be something like this. If you had 2 over 4, that's a bad one. Don't go with that. Don't do that. Just kidding. Let's do like 2 over 10 times 5 over 6. Okay, and so we could multiply that, and we could get 2 times 5 is 10 over 10 times 6 is 60, and then we'd have like the 10 over the 60, and we could simplify from there, which in this example would not be bad. But what we're going to do is we're going to factor instead, and we're going to recognize that 10 is 2 times 5, and we have like a 2 times 3. This was a bad example, and that's what I get for making up examples on the fly. But we would cancel out the common factor of 2. We would cancel out the common factor of 5. And then we would be left with 1 in the numerator, and 2 times 3 is 6. Now we could have gotten there by, again, like multiplying straight across and getting 10 over 60 and then simplifying that to 1 over 6. But generally speaking, we can avoid some of those bigger numbers if we're willing to simplify first. I do want to point out real quickly, though, that when you're canceling out your common factors, it's always a numerator with a denominator. Always, always, always a numerator with a denominator, because something divided by itself is 1. And so 5 divided by 5 is 1, and that's why it cancels. This 2 right here at the bottom cannot cancel with this 2 over here. Okay, you cannot cancel like a denominator with another denominator. It's always a numerator factor with a denominator factor, again, because anything divided by itself would be 1. So what would this look like in a rational expression? So get ready for the fun to start. I have to make sure I copy this correctly. And I'm saying fun in a nerdy math sort of way. Okay, so we have x squared minus x minus 6 over 2x squared plus 5x plus 2. And we are multiplying that by, that is a that's multiplication. 2x squared minus 7x minus 4 over 3x minus 9. Okay, and so we've got to factor all this, and I don't have enough space on this screen to like lay out all the area models and keep them on the screen. So what I'm going to have to do is I'll designate like a chunk of the screen over there for the factoring, and then I'll have to do one and then erase it and then move to the next one. So we'll start with, I guess, the first one. We've got x squared and we have a -6, and we're looking for 2 factors of -6 that will add up to, remember, this is a -1. And so my factors of -6, I could have 1 times 6 or 2 times 3. 2 times 3 is the pair that will give me the -1, only if the 3 is a negative. And so I will have 2x and -3x. X squared factors into x times x. This will be a 2. This is a -3. And so my first factoring is x plus 2 over x, or times x minus 3. And you'll notice that unlike earlier in the year, pause and copy that down if you need to. Earlier in the year, you just have one factoring problem. Like this one problem involves 4 factoring problems. And so it is pretty intense on the factoring. So we've got that going on. All right, next one. We've got the denominator there. So we've got 2x squared will go in the upper left, and we have a +2. And remember, when you have that leading coefficient, we're going to have to multiply them to get 2 times 2 is 4. And I am looking for 2 factors of 4 that add up to 5. That would be 1 and 4. And so we will have 1x and 4x. You'll notice I'm doing the factoring pretty quickly. We reviewed that a lot in the last lesson, and we could get really bogged down with it now, and I don't want to. Greatest common factor between 2x squared and 1x is just x, which means my 2x is on the top. This is a 1. This would have to be a 2. And so my other set of factors is 2x plus 1 and x plus 2 over here. Okay, and pause and write that down if you need to. You can always rewind the video, I guess. All right, next one. We've got 2x squared and -4. And again, we have that leading coefficient, so we have to do 2 times -4 to get -8. and I want two factors of -8 that add up to -7. That'll be a +1 and a -8. And once again, we'll have the GCF of 2x squared and 1x is x, making that 2x, this 1 and this 4. Double check all that. And so on this one, we have 2x plus 1 and x plus 4. And then our last one, pause the video if you need to grab that factoring work. And on this last one, oh, I erased my little line there. It's okay. 3x minus 9 just has a GCF, and so it's got a common factor of 3, and that would leave me with x minus 3. And when you're doing problems like this, especially when you're in a unit on rational expressions, you're expecting a lot of stuff to cancel. And so we've got several common factors here that we can cancel out. Remember, it's always a numerator with a denominator. So I have an x plus 2 that can cancel with an x plus 2. But remember, because when you're multiplying the fractions, everything in the numerators all kind of like merges into one numerator, which means that I can take this 2x plus 1 that's in a denominator and cancel it with that 2x plus 1 that's in the numerator, because when I multiply them, they would actually end up in the same fraction. And I can do the same thing with the x minus 3's. And then when everything is said and done, I have an x plus 4 in the numerator and a 3 in the denominator. So a lot of work. You can see why we maybe save this unit for last, but not super, super difficult concept. Just it is a decent amount of work. So that is our first video lesson on multiplying rational expressions.